So folks, I'm going to talk briefly about this idea of a contract service provider, which is the analog of the internet service provider, the ISP model that we have taken for granted, but it did not happen magically. There was a lot of discussions in the 90s, into the 2000s, and partly it's because it's motivated by this problem, and I don't need to talk about this at all because for the last 2 days, 3 days, we've heard a lot about this transaction. Um, there is a relationship between system interoperability and the cost of transactions, right? So in a sense, the rising cost of transaction is a form of platform capture, just in the way that social media platforms, think of Twitter and Facebook. They've been accused of creating this capture where the end user, the home use is addicted to Facebook, and they keep posting stuff, and this causes other side effects that in fact it's quite surprising that there is really a lack of interest amongst the technical community, the developers, to seriously address the problem of cross-chain interoperability, and I'll talk a bit about some projects that are kicking off in the ITF around this. So there's this other question that is what does it mean to invest in infrastructure? So if you look at the history of the internet, in fact, it was DARPA that invested a lot of money in those days into research and actual building hardware for the internet infrastructure. And I don't see the equivalent happening. Yes, I see people putting up mining nodes and forging nodes and so on, but is that infrastructure, right? That's an interesting question. And also the last bullet there is interesting, that people don't want to talk about the diversity of the node stack, the software and hardware that make up these nodes, right? So in fact, even NIST sort of pointed this out. So it's a matter of time before we will see viruses and malware that are specifically designed for specific types of nodes being unleashed, a zero-day attack. And when that happens, we'll have crippling effect on the network. So today I wanted to talk about smart contracts and this idea of contract primitives. And we've been looking at a lot of the smart contracts being written for Ethereum. And one of the things that we've noticed is almost that there's no programming discipline being used here. That this there's a confusion, I think, that's happening, that this model, the thin client fat server model that has been popular. Thin client means you've got a browser and all your software and complexities is in the application that sits in the cloud. Well, a smart contract on a node is not the same as a server in the cloud, right? So there's this tendency of just shoving in so much complexity into your contract that in a sense it becomes bloated, and it creates vulnerabilities, issues, security issues, and the more complex, the more a number of operations. And so if the cost of transaction is tied to the number of operations, and that's tokenized, then essentially you have to pay more. And so what's an alternative model? There's a thing called function as a service, right? So this is an interesting concept that's just sort of emerging right now. We've heard of software as a service in the past, with Salesforce being this company in San Francisco being one of the probably most successful companies leading this forge. We've heard of infrastructure as a service. We've had platform as a service. And in fact, there is a blockchain as a service, BaaS, that's being offered by some vendors out there. I shall not name names, but what we want to focus is on the idea of standardizing around contracts and having the contracts being the unit of action versus the entire nodes, right? And so if that's the case, then we need to focus on very well-defined small contracts that do very specific things for very specific assets, right? And we'll talk about this contract service provider as the entity that would be offering this service. So it looks something like this. So left hand side you have a contract domain, just an area where it consists of a number of nodes or service providers. So in this diagram, you have service provider CSP A, B, all the way to N. Pick a number, and for simplicity, they're just doing one contract, which is C1. And for that contract C1, there's a number of policies. There's a ledger that they share that's specific to C1 and all the data associated with the contract. And of course, they run a consensus protocol. And so this unit, those four functions, could be containerized today using containerized, technology for virtualization, independent of the hardware underneath, right? So this is a unit that could be launched just the way you could do this today on Amazon Cloud. You can launch container units within seconds, right? And so using this model, we are asking ourselves, could a set of business entities get together and say that they want to create their own network based on some design principles, based on some contract design rules, where they focus on specific types of assets and specific operations. So this puts a different sort of slant on the question of interoperability, because now we can say, well, if you have two communities, two groups of nodes, and they're basically implementing the same contract, C1. So C1 and C2, this is in the diagram in the middle there, there's this semantic interoperability. They do the same thing. Well, why not just standardize the contract, right? Write it in pseudocode and have 2, 3, 4, 5 different language implementations, and do testing and so on to make sure that the outcome is the same, that the simple function being done by C1 is the same as the function being done by C2, right? And so this is the motivation. And the idea of a CSP is that just like an internet service provider, it can offer subscription fees versus mining fees or forging fees. Why? Well, because the number of operations are predictable. If a contract has 15 operations, and the cost of putting up this image up in the cloud is fixed, then basically a service provider, a CSP, has a sort of rough idea of how much the business is going to cost. So this is exactly like internet writing domains, and we kind of joke here. I mean, if in the 90s the ISPs decided to charge people on a per packet basis, based on some kind of proof of work, we would never have the internet. We would not be doing Zoom. We would not be watching Netflix, during this pandemic, because it'd be too expensive, right? And so that's why we think that looking back, how did the ISPs pull this off? And yes, there was a lot of competition in the 90s. There were no rules, basically, right? And ISPs themselves had to get together and decide on the standards and decide on a thing called peering agreements, basically peering contracts, paper contracts, to allow packets to flow through different networks. So that's kind of the model. And so this is the idea of a contract domain. Back again, you just one contract domain X, one contract domain. Everybody there is implementing one type of contract set of primitives. Make it easier. They're sharing a per contract ledger. They've agreed on one consensus algorithm. Pick one, they can decide. And there's some domain policies. And domain policies means things like, well, before you do cross-border asset transfers, well, maybe you need to do some compliance AML checking, like maybe the contract service provider, being a VASP, they need to comply to the travel rule. Right. So if you read the literature, particularly the research literature on abstracting the smart contracts model and doing cross-chain hash locks and so on, the whole discussion about travel rule and strong identification and authentication of entities it's pretty much absent. It's almost like people don't want to talk about it. But in the real world, when you are moving real world assets, you have to, pay attention to these AML, and KYC, regulations within each domain, and each jurisdiction, and each legal jurisdiction will have its own set of, requirements. Here's another example. So this is just to illustrate. So here's basically 3 different domains, call out 3 different communities. First one is contract domain CD1 running contract C1. It only has 2 constituents, A, service provider and B. Contract domain 2, the second one in the middle, it has 3 business entities running, contract C2, right? And same with contract, CD3 here, C3. And so the whole point of this diagram is to tell you that today you have the capability to create executable images in the cloud for each one of these contracts. So C1, C2, C3 can be images that are prefabricated, just compiled code that a provider can boot up in a matter of seconds, right? In fact, you and I can do that in a matter of seconds. And there's a lot of work, creating the image that contains the contract. But once it's done, it's done. The idea of communities. So CSP communities are like, ISP, communities where the providers get together. They agree on some common operating rules. So operating rules exist today in different networks. So if you think of, in the banking space, there's Visa and MasterCard. And if you're a bank and you want to join, the MasterCard, network, you have to observe their operating rules. And there's some, a list of, technical specifications as well as business rules that you have to, sign on to and agree to abide. And so, it's nothing new. And the same with the internet. There are peering agreements that you can look up, between internet providers. And so what's interesting here is that you can make agreements based on a contract-centric agreement that a group of people will say we're going to implement contract C2. How a member actually instantiates nodes, whether it's in the cloud or bare metal, it's really up to them. But the end result is they have to have this shared contract domain where they share the ledger, they agree on running this consensus algorithm, and so on. So future work, I'm kind of running a bit fast here, observing the time. So one of the missing components is interoperability. And given the history of the internet, so the internet work was that, there's a routing domain, and if you're an ISP that owns a routing domain, you have the freedom to buy any hardware you want, any router you want. You can use whatever protocol you want to route traffic within your domain, because that's your domain, and that's the definition of an autonomous system. Now the problem is when you're trying to connect 2 autonomous systems together, you need a standard protocol, what is called a gateway protocol. So in the internet, there are a number of specifications. The most famous one is BGP, Border Gateway Protocol, and the name says it all, which is to allow transfer of packets across 2 different domains or 2 different autonomous systems. So we think that maybe a plausible, given the complexity that's emerging in different blockchain systems, that you need to borrow this concept of a gateway and define a gateway protocol. And so we're beginning this work in the Internet Engineering Task Force. So the IETF is in fact the home of TCP/IP, HTTP, SSL, all the things that we take for granted today as we sit at home, using the internet, was developed in the IETF. It is a neutral entity. It doesn't own any particular project, doesn't own any particular code. It produces standard specifications. And so we're developing this protocol there so that it provides some means to allow assets to flow. So if Alice, an originator, in a particular blockchain network, is wishing to transmit, move or migrate assets to Bob, in blockchain B2 on the right-hand side, then Alice could do that, and this should be done automatically with observing the a number of transaction properties, atomicity, consistency, durability, all the standard requirements for transfers. Conclusions. CSP model, we think it's promising, and we think that the price of transactions really need to be fixed in order to make this affordable. There's a lot of interest in making financial inclusion, but clearly just looking at Bitcoin, Bitcoin doesn't really, to me at least, it doesn't help financial inclusion. There's a lot of lessons to be learned from the internet architecture, a lot of the same kinds of debates and issues and challenges. We need to look at contracts as in this model of function as a service, FaaS, and also look at interoperability by way of the gateway protocol. Here's some related papers. If you want a copy of the slides, I think I can give this to Francesco maybe. And the organizers, or maybe Jeff, or email me if you want a copy of the slides. And if you want more reading in this pandemic season, and you have and the restaurants are all closed and you're stuck at home, well, here's some reading to put you to sleep at night. Thank you, folks. If any questions, feel free to speak up or put in the Q&A.
So thank you, Thomas. So we have one question from Joubert. How would the Open Digital Access Protocol, or ODAP, interact or enhance this model for contract service providers?
Great question. So ODAP is the protocol that we are sort of developing and growing in the ITF, and it addresses this gateway and model, and more interestingly, it talks about APIs. So when you look at the spec, it just defines APIs of the gateways, and how you implement the gateways, it's really up to each ISP. And the idea is that this could class of vendors who are building gateways, whether it's hardware, whether it's complete stacks or applications, that they can then help sell into the financial sector in order to connect these different networks, because networks are emerging, right? There's private networks. There's JP Morgan Coin, right? Which is a community, and then there's a community of people in Singapore. That these are closed, and this is the internet is like this. It's closed networks. It's not all wide open the way people think the Bitcoin is, right? It's nothing like that. And so gateways were needed to begin with, and I believe it's going to be needed here.
Thank you, Thomas. So now earlier, when you mentioned that there would be consortiums of businesses that would work together, the question seems to always come up in distributed ledger technologies that if a consortium is friendly enough to work together, why would they need a system to facilitate arm's length transactions? If we remember the lessons from the IBM Maersk initiative in distributed ledger technology, everyone thought that it was for their benefit. Now, it sounds like what you're describing when you reference BGP and the peering relationships among network carriers in the internet world, you mentioned that the internet really succeeded because the carriers weren't capturing end-to-end value. Now, how do we demonstrate that there isn't going to be a way for either the carriers, which is to say that the equivalent of carriers in your context, or the jurisdictions, regulators in which they interact, to be capturing end-to-end value? How do we know that the value will all be captured at the edges?
Right. So you mentioned some good examples there with Maersk and so on. So the analogy today, in terms of timeline, we are exactly very much between 1985 and 1989, and I mentioned that 4-year, 5-year gap because in that period there were in the networking world there was no standard, there was no real internet IP. TCP/IP was not yet RFC, and so you had IBM with SNA token ring. There was Ethernet, there was DECnet. So if you were a company and you bought equipment from, say, DEC, Digital Equipment Corporation, you're stuck, right? And there was no TCP/IP across these networks, private networks. And so one of the things that the U.S. government, particularly the DARPA and the DoD, did right is basically say to these vendors, look, we're not going to buy any of your hardware if it does not, have interoperability based on standard protocols, right? The DoD did not want to be locked into one particular hardware vendor, because the vendor could die in the future, and you'd be stuck, right? So the same thing needs to happen. And this idea of a CBDC is an opportunity. So if the UK government says, okay, we want to experiment in CBDCs, then you have to list out some principles. We're not going to be stuck with any particular consensus algorithm. We don't want to be stuck in any particular, asset, interpretation or asset format. Right? So the way this is actually where government could help, in stating, requirements for interoperability.
So governments often work with standards organizations. Are you talking with ISO, like ISO TC68 financial services, or TC 307 blockchain and distributed ledger?
Presentation there, and I think there is
yeah. So also ISO TC 307 blockchain and distributed ledger technologies. This could also be an interesting venue for this.
So I think the way protocols typically happen is it goes through it gets beaten up to death in the ITF. People hammer it. It's like a piece of metal. You hammer it into this kind of crazy shape, and then once everybody's happy, then it's deployed, and then it percolates up, becomes national level standard, and it's ISO standard.
Yes, rough consensus and running code, I think, is the IETF way.
Yes, so you remember that. Yes, that's good.
Yes.